Good morning, students. This is the fourth lecture for lead modification and structure activity relationship study of some drugs. Now, in the previous lecture, we studied about the structure activity relationship of a sulfa drug. There are two more drugs left over in the syllabus for their structure activity relationship studies. One is Taxol analog, another one is benzodiazepine drugs. Benzodiazepine drugs. Now coming to structure activity relationship study of Taxol analog. I have written already its structure as its structure is complex on a board. Structure activity relationship study of Taxol analog. Now this is the structure of Taxol analog. It is an anti-cancer agent. Now Taxol analog is used as a anti-cancer activity or anti-cancer agent. Now its a structure consisting of, this is ring A, 6-membered ring, cyclohexene ring, 6-membered ring. The other ring is 1, 2, 3, 4, 5, 6, 7-membered ring. This is 7-membered ring. Ring A is a 6-membered cyclohexene. Ring B is a 7-membered. Ring C is 1, 2, 3, 4, 5, 6. Ring C with 6-membered and ring D with 4-membered ring. So Taxol analog consisting of, it is a tetracyclic system, ring A, ring B, ring C and ring D with a substituent. Now positions are designated. This is first carbon, second carbon, here third carbon, fourth carbon, fifth carbon, sixth carbon, seventh carbon, eighth carbon, 9th, 10th, 11th, this is 12th carbon, 13th carbon. Now the first carbon bear OH group, the second carbon consisting of benzoyl oxy group, benzoate groups or benzoyl oxy group, and third carbon has no substitution, fourth carbon has OAC, and fifth carbon has no substitution. There is no sixth carbon substitution. Seventh carbon has a OH this is OH substitution. Eighth carbon has a CH3 group. Ninth carbon has carbonyl C double bond O group. 10th carbon again has OAC group. 11th carbon has no substitution. 12th carbon has a CH3, this is CH3 group, and 13th carbon has a side chain of O C double bond O CH2 CH2 N, this is NH group, NHCOPH, a side chain designated with 1 prime, 2 prime, 3 prime carbons. Side chain carbons are designated with 1 prime, 2 prime, 3 prime carbons. 1 prime carbon has a C double bond O group, 2 prime carbon has OH group, 3 prime carbon has 1 phenyl group, 3 prime carbon also has 1 NHCOPH group. So this is the Taxol analog. Now coming to its structure activity relationship study. Now its structure activity relationship study indicated that number one, now among A, B, C, D rings, ring D is essential for activity. The presence of ring D is essential for its anti-cancer activity. When we change the ring D or when we remove the ring D, it loses its activity. So that the presence of ring D is essential. Number two, OAC, removal of OAC at 4th carbon. This is 4th carbon. The second activity relationship study, this is the 4th carbon. Removal of OAC group at 4th carbon decrease the activity. OAC at 4th carbon decrease activity. So removal of OAC group at 4th carbon which decrease its activity. Next, number 3. The third structure activity relationship study. Now PHOAC group at second position. Where is second position? This is second position consisting PHOAC group, benzoate group. Now presence of benzoyl oxy substitution at second position is also essential. PHCOO group at second position. PHOAC group at second position is essential. Now the fourth one, presence of this phenyl group and presence of amide group. This is PH group. Now this is NHCOPH amide group at 3' carbon. Presence of one phenyl ring, the other amide ring at 3' carbon is also essential. PH and amide at 3' carbon is essential. Their presence, these two groups' presence is also essential. Now the other groups on 1' carbon, that is C double bond O, the substituent on 1' carbon where there is a C double bond O, at the second 2' carbon is OH group, and 3' carbon, these two groups. So presence of a substituents on 1', 2', 3' carbons are also essential. 1', 2', 3' carbons are so presence of a substituents on 1', 2', 3' carbons on a side chain. 1' is a C double bond O, 2' is a OH, 3' has one phenyl ring, one amide ring. So substitution on 1', 2', 3' carbons are also essential for its activity. Is it clear? That is, now coming to the other, the OH group at 7th position. Here it is. Now this is 7th position. The presence of OH group on 7th carbon has no significance. No OH on 7 has no significance. The OH group, the presence of this OH group on 7th carbon has no significance. Now the other now reduction of CO group on 9th carbon. A carbonyl presence on 9th carbon, when it is reduced, its activity will be improved. 9th CO reduction improve the activity. Now reduction of carbonyl group on 9th carbon improve the activity. Now the other, this OAC on 10th carbon, OAC on 10th carbon has no significance. Whether it can be replaced or not. OAC group, presence of OAC group on 10th carbon has no significance. It can be replaced. There is no change in the activity. Now the last one, the configuration on 1' carbon, 2' carbon, 3' carbon is also essential for its activity. Configuration on 1', 2', 3' carbon. So side chain configuration is also essential. So side chain configuration is also essential. So this is about brief structural activity relationship study for a Taxol analog, which is anti-cancer drug. In brief, it consisting 4 rings: ring A, ring B, ring C, ring D. Ring A is 6 membered, that is cyclohexene. Ring B is 7 membered. Ring C is 6 membered, cyclohexene. Ring D is 4 membered. So presence of ring D, 4 membered ring, is essential on 4,5 carbons. OAC on 4th position. When we replace OAC group, which is present on 4th position, which decrease its activity. Now presence of the phenyloxy group at 2nd position is also essential for its activity. Now phenyl group and an amide group on 3' carbons in the side chain are also essential for its activity. The substituents on 1', 2', 3' carbons are also essential for its anti-cancer activity. The OH group presence on 7th carbon has no significance. It may be replaced with the other. There is no change in the activity. That means that its presence on 7th carbon, it has no significance. Next, reduction of carbonyl group, which is present on 9th carbon, improve its activity. It can be reduced in order to improve activity. Now OAC at 10th position has no significance. Now configuration of the side chain, that is 1', 2', 3' carbons of the side chain configuration is also essential for its anti-cancer activity. So this is about structure-activity relationship study of Taxol analog. Now this study indicated what to do, what not to do to improve the anti-cancer activity. That is, number 1, reduction of C double bond O group on 9th position improved its activity. So by the process of reduction of C double bond O, we can improve its activity. To retain its activity, we should not touch the other groups which are essential. So this is about structure-activity relationship study of Taxol analog. Now we have to study one more drug, that is benzodiazepine drug. The third one, structure-activity relationship study of benzodiazepine. Structure-activity relationship study of benzodiazepine drug. So this is the drug consisting of a benzene ring fused with a 7-membered ring, where the 7-membered ring contains 2 nitrogen. Therefore, 2 nitrogen diazar 7-membered ring epine, benzodiazepine. Its structure. So this is benzene ring. This is nitrogen. One more nitrogen. Now a benzene ring with fused with a 7-membered ring, diazepine. Now there is a double bond. This is phenyl ring. This is one substituent, R3 substituent. This is C double bond O, carbonyl group. Nitrogen has R2 substituent, any substituent. This is R1 substituent. Now its numbering starts from nitrogen 1, carbonyl 2, this is 3rd, this is 4th, this is 5th. Now this is 6th, 7th, 8th and 9th. So this is about benzodiazepine drug. Now it's a structure-activity relationship study. It is a simple drug, it has a simple structure. Now it's a structure-activity relationship study. The substitution of R2 group on N1, that is first nitrogen, this R2 group, substitution of R2 group on nitrogen of first position does not change its activity, does not change its activity, does not improve its activity. So the substitution of R2 group is has no significance. R2 substitution has no significance. We can substitute easily by other. R2 group substitution does not improve its activity, does not significantly improve its activity. Now, the substitution of R1 group at 7th position by any group. Now, this is 7th position. Substitution of R1 group at 7th position by any group improve the activity. R1 substitution improve the activity. So substitution of R1 group on 7th position, 7th carbon, improve its activity. Now, other one, the substitution of 6th carbon and 9th carbon has no significance. There is no change in the activity. So C6 carbon, C9 carbon substitution has no significance. These two substitution has no significance. Now, coming to the 5th carbon. The phenyl ring on 5th carbon is essential for its activity. Phenyl ring, presence of phenyl ring on 5th position is essential for its activity. pH at 5th position is essential for its activity. Now, further, any electron withdrawing group, if substituting on a phenyl ring, so presence of phenyl ring is essential for the activity. If we substitute the hydrogen of phenyl ring on 5th position by any electron withdrawing group, improved its activity. Electron withdrawing group on 5th position of phenyl ring improved the activity. Its activity will be improved when we substitute the hydrogen of phenyl ring presence on 5th carbon, improved the activity. Is it clear? Now, reduction of C double bond N group on 4th position, that is reduction of C double bond N between 4th and 5th carbon decrease its activity. It should not be reduced. The double bond is essential. Double bond should not be reduced. That is CN reduction decrease its activity. CN reduction decreased its activity. Now, change of C double bond O carbonyl on C2 carbon by any other like C double bond S decrease the activity. Now, C double bond O at 2nd carbon, if we changed by other, if we replaced by other like CS, C double bond S, decrease the activity. Its activity will be decreased. So it is essential. Now, C3 carbon. Now, substitution of R3 on C3 carbon by electron withdrawing group improve the activity. This is R3 with electron withdrawing group, improve its activity. Activity can be improved by substituting R3 group on 3rd carbon atom of diazepine ring, improved its activity. Now, last one, when the C double bond O group on C2 carbon is involved or conjugated with nitrogen atom by the other, that is C2 carbon atom, that is C double bond O oxygen and nitrogen, if we involved or if fused with the other ring. Are you following? C double bond O group on second carbon and nitrogen on first position, if fused by the other rings, can improve its activity. C double bond O and nitrogen together fusion improve its activity. So this is about structure activity relationship study of benzodiazepine in brief. So it has a two rings, number one. Now coming to structure activity relationship study of each and every position. Now substitution of R2 group on nitrogen 1, first position, that is on nitrogen, has no significance. There is no significant change in the activity. Now modification of C double bond O group at second carbon decrease its activity. Substitution of R3 group on third carbon atom by electron withdrawing group improve its activity. Reduction of C double bond N between C4 C5 carbon decrease its activity is essential. Presence of phenyl ring on fifth carbon is also essential for its activity. Further, its activity will be improved when the hydrogen of phenyl ring is substituted by any electron withdrawing group. Are you following? Now, substitution on sixth position has no significance. Substitution of R1 group on seventh carbon improve its activity. Now substitution of 8th and 9th carbon by any other does not change its activity. So this is about structure activity relationship study. So we should not replace C double bond O group by the other, we should not modify. To improve activity, we can substitute R3 group by electron withdrawing group, or substitution on phenyl ring of C5 carbon improved activity. Substitution of R1 group at 7th position improved activity. So substituting R1 group or R3 group or hydrogen of phenyl ring improved its activity. So we should not reduce the C double bond O. So this is also essential. Now last one. If a C double bond O and nitrogens are fused or involved, fusion with the other carbon or with the other ring improved its activity. For example, this is benzodiazepine, this is R2 group, this is C double bond O. If C double bond O if C double bond O as well as nitrogen is involved in the fusion with the other ring, improve the activity. For example, so this is second carbon. Now a nitrogen and a C double bond O group. This is NH group. This is nitrogen, double bond nitrogen, a CH3. Now it is alprazolam. Alprazolam, where R1 is equal to chlorine, R3 is equal to hydrogen. R3 is equal to hydrogen. It is known as alprazolam. It is a drug of benzodiazepine. Now, it is a developed one based on the benzodiazepine structure. You can see what happens. What is the modification? A C double bond O group and a nitrogen on 1,2 carbons are involved to fuse with the other ring so that its activity will be improved. activity will be improved. Now, in other way, the activity can be improved by changing R3 group. If R3 is equal to electron withdrawing group, any electron withdrawing group enhance the activity. Similarly, substitution of benzene ring by electron withdrawing group improve the activity. So in this way, the structure activity relationship study helps us what to modify, what not to modify, to minimize all the unwanted properties, unwanted physical properties, as well as to eliminate the toxicities, as well as to improve the activity of the drug. So this is the significance of structure activity relationship study. After studying structure activity relationship study for a benzodiazepine, we have some idea what to do to improve its activity. A simple way, we can replace R1 group by any other to improve activity. We can substitute R3 group by electron withdrawing group, improve activity. We can substitute hydrogen of phenyl at 5th position, improve its activity. And we can fuse the other rings involving N1 and C2 carbon, C double bond O at 2nd carbon and nitrogen on 1st carbon, improve its activity. Just now we seen in the alprazolam drug. So this is the way. Now with the help of structure activity relationship, we are able to improve the activity by modifying the structures. So this is about significance of benzodiazepine drug. So with this, the structure activity according to your syllabus, you have to study the structure activity relationship study for sulfa drug, for Taxol analog and for benzodiazepine drug. In the last class, we completed about sulfa drug structure activity relationship study, and in the today's class we covered the two structure activity relationship studies for two drugs. So one is Taxol analog, another one is benzodiazepine drug. So with this, the total syllabus of second chapter for paper 1 is completed. So the total syllabus include structure lead modification, lead structure modification include 11 strategies to modify the structure. So we studied about 11 strategies. So syllabus also include 4 drug discoveries: oxaminoquin, cimetidine, captopril and salbutamol. Oxaminoquin was covered in this lecture, in the previous lecture. Salbutamol and cimetidine and captopril were covered in the first chapter. So discovery part is over. Now structure activity relationship study for 3 kind of drugs: sulfa drug, benzodiazepine and Taxol analogues. This is about syllabus for lead modification and structure activity relationship studies. So with this, I completed today's lecture. As the syllabus is over, and send this link, video link, through a WhatsApp group, and also regarding the notes for this lecture through a WhatsApp group. You please listen my lecture carefully and write down the notes and learn the chapter well and execute your performance in the final end semester examination. So with this, I complete my today's lecture. Thank you very much for patience towards the listening my lectures, bearing me since first semester to fourth semester. This is fourth semester. Unfortunately, we have no opportunities to teach you directly sitting in the classroom, so that I have provided a video lectures during the pandemic situation or pandemic conditions. So this is a very bad experience to me. as I am unable to directly teach to you in your 4th semester, as you are the final year students, that is outgoing students, there is no chance again to teach you in the classroom. Thank you very much.